Hey everyone, welcome back. Okay, we are diving straight in today. This explainer is all about a literal paradigm shift in AI news. We're talking about OpenAI's July 9th release of GPT 5.6. Look, if you've been building with AI recently, you already know the hurdles, right? But this update, it fundamentally rewrites the intelligence per token ratio. We're going to break down exactly what this means for your daily workflows and, honestly, your entire application architecture.
Here's our quick roadmap for today. We'll start with the production bottleneck, dissect the raw performance of GPT 5.6, check out the news Sol tier, talk about flattening your tech stack, and wrap it all up with a concrete developer playbook. Let's get to it.
Section 1. The production bottleneck. Let's talk about stalled AI agents and why so many of those early GPT-5 prototypes just ended up abandoned.
So if you've ever tried to push an autonomous agent into the wild, you've definitely asked yourself this exact question. Why do AI agents stall in production? You build this absolutely brilliant proof of concept on your laptop, right? It works flawlessly. But the second it hits live users, bam, it inevitably hits a structural wall.
And honestly, these are the usual suspects causing those massive headaches. Your context windows were just getting filled with absolute garbage. We're talking redundant reasoning traces where the model just kind of thinks out loud for no reason, repeated tool invocations that go completely nowhere, and those dreaded fallback hallucination loops. And the direct result of all this friction? Painful runaway token costs that completely blow up your API budget. No one wants that.
As the postmortems across the industry have repeatedly shown, context windows fill with redundant reasoning, repeated tool invocations, and fallback loops. Previous iterations prioritized raw capability, sure, but they really acted more like drafting assistants. They required so much heavy manual prompt engineering just to keep them on the rails.
Section 2. Enter GPT 5.6. This right here is OpenAI's direct, highly optimized response to all that painful production feedback. This release centers on 3 measurable shifts that massively compress the path from your intent to the model's actual execution. We're looking at optimized token efficiency, massively enhanced cost performance, and advanced autonomous capability. Basically, the model is now positioned as efficient by default. It delivers maximum performance on demand without all the expensive bloat.
Now, the standout metric you absolutely need to remember is 24%. When using their new tool calling methods, GPT 5.6 consumes 24% fewer output tokens. Guys, this isn't just a rounding error. It completely changes the unit economics of every single API call you make. It slashes your inference costs and takes a huge load off your downstream parsers.
But wait, it actually gets better. Alongside that massive token reduction, the model completes tasks 28% faster. Think about what that does to your user-facing latency. If you're building chatbots, automated research agents, or code gen tools, your users are going to feel that 28% speed boost instantly. It's a real game changer.
So, what's the secret sauce behind these crazy numbers? It's something called Programmatic Tool Calling. This is the key architectural shift of the whole update. Instead of those verbose reasoning traces where the model explains every little thing it's doing, we now get compact, highly executable outputs. It efficiently handles tool selection and parameter generation internally, completely replacing all that heavy, manual prompt scaffolding you used to have to constantly maintain.
And we can see these concrete gains playing out in the real world through third-party evaluations like Rogo's Big Finance Benchmark. Compared to the old GPT 5.5 baseline, GPT 5.6 improved rubric quality by 6.2 points, and answer accuracy jumped by 3.6 points. So you're getting faster, cheaper outputs that are actually demonstrably higher quality. It's wild.
Section 3. The Sol tier. Now, for those of you needing even more horsepower, OpenAI introduced a highly specialized tier targeted squarely at complex reasoning and autonomous sub-agent orchestration. The Solve tier officially graduates AI from being a mere drafting assistant into a true execution layer. Just look at the shift in capabilities here. For complex tasks like accounting, Solve inspects, refines, and delivers ready-to-use results. No more heavy human oversight required. For multi-step code refactoring, it handles autonomous execution outright, replacing those super rigid orchestration frameworks we used to rely on. It just has much stronger design judgment and handles error recovery with barely any steering. And because Sol can maintain intense focus over extended, long-running sessions, it's absolutely perfect for security engineering. Workflows like secure code review, automated patching, threat modeling, and blue teaming receive major targeted improvements.
You can now plug this directly into your continuous integration pipelines for really thorough dependency scanning and vulnerability triage without constantly stressing about hitting context limits.
Section 4. Flattening the stack. Because the model can now maintain strict focus, this directly impacts how you should actually structure your builds moving forward.
This brings us to the core architectural debate: heavy middleware layers versus delegated model logic. See, the old way of building meant wrapping the LLM in multiple middleware layers just to enforce state tracking and tool routing. The new way? You just delegate that logic directly to the model. You no longer need to chain explicit tool invocations in complex, messy wrappers.
Now, the new architectural trade-off looks like this. Higher initial configuration complexity yields a significantly lower long-term maintenance burden. Yes, for sure, you have to be meticulously precise when setting up your guardrails on day one. But once you do, your maintenance burden basically drops off a cliff. The model just handles the execution for you.
Section 5, the Developer Playbook. Let's put all this theory into practice and figure out how to leverage these new unit economics right now.
Here is your structured to-do list. First, audit your current tool calling architecture. Ditch those verbose prompt templates for programmatic tool calling. Second, test the SOL tier specifically for your multi-step workflows to see what it can handle. Third, update your cost models. Fourth, implement your guardrails. And fifth, refactor those agent loops to flatten out your orchestration stack.
Actually, I want to pause on step 3 for a second. Recalculate your API budget projections. Seriously, with a 24% reduction in output tokens and way faster cold starts, your inference is substantially cheaper now. Before migrating your production traffic, you really need to sit down and rerun your math, because you are very likely going to save a lot of money.
And regarding step 4, implementing guardrails? Yeah, this is non-negotiable. Because the model has so much higher autonomy and requires less steering, it inevitably introduces a larger execution surface. You absolutely must use structured output validation, strictly define your tool permission scopes, have rock-solid fallback mechanisms for long-running tasks, and always verify outputs with deterministic post-processing steps.
To help you execute this playbook, here are the core resources you're going to need. You can find the official docs and API references directly at openai.com/index/GPT-5.6. For awesome community-driven prompt libraries and integration examples, definitely check out the Anil Macha awesome GPT-5.6 repo on GitHub. And if you want to dig deeper into that third-party workflow data we discussed earlier, those benchmarks are published by Rago.
Well, we've covered a ton of ground today. From solving the production bottleneck to leveraging the massive efficiency of programmatic tool calling, all the way to the raw power of the SOL tier. So I want to leave you with this one provocative question to chew on. Is your application actually ready for an autonomous execution layer? Honestly, it might just be time to revisit those abandoned agent prototypes and start refactoring. Thanks so much for learning with me today, and I will see you in the next explainer.